Yes. Now, yes. Good evening. So we'll do today class is ray optics. Okay. Ray optics. What optics? Ray optics. Please take the books. Open the books, everyone. Now, can you please tell what is this chapter? Ray optics. What is optics means? What is optics means? Simply time is waste. Optics means what? What optics means, Jashmita? Hmm? You don't know. Okay. So optics is a branch of science. It's a branch of science study about the light. It's a branch of science that too in physics. Okay. Physics deals with the study of what? Light. Deals with the study of light. Study of light. That is what we call optics. You know what is light? What is light? Yes. Light behaves like a wave or a particle. That's fine. What is actually light? You studied from first standard to 10th standard. What is light? Light is a form of something you are telling. No? What, for example, from sun light will come, right? What is actually in light? What will be there? That's a ray optics. Huh? Some light is carrying what? Yes, energy. You studied, no? From first standard, you are not from first standard, some standard. You know, light is a form of energy. Correct, right? Light is a form of energy. Form of energy. Heat is a form of energy. Light is a form of energy. Okay. Light carries heat with it when it is traveling from sun to the earth. Okay. You know that. Next, what else you know about light? But when you come to the level of 12th, you when you come to the level of the top highest studies on 12th, you will understand light is not just a form of energy; it's an electromagnetic wave. Okay, that you will study. Before we are going to the big concept, we'll just listen what is light first. Okay, light is a form of energy. Now, light consists of so many particles. Lights consists of particles. What particles they are? Okay, not nothing. Okay, so if the study of light is started long before, okay, and when you start, seeing light, it will give heat. It will be in the form. It has so much brightness. Its velocity is maximum. Light will fast. It will move very fast. The speed of light is more. You know what is the speed of light? What is the speed of light? 3 into 10 to the power of 8 meter per second. That's the speed of light. C, celeritas or swiftness. It is swift. Light will swift actually. Its velocity or speed is 3 lakh kilometer per second, 3 into 10 to the power of 8 meter per second. This all you know. That's what I am discussing. This chapter is nowhere connect with this velocity and all, but just about light. Okay, you people already said light is made up of photons, light quanta. Light is see all of them, all of the scientists, they are trying to understand what is light. It was so curious for them. Oh, light, something is coming from where? Sun. It's when it falls on the surfaces, it is illuminating. How it's possible? There are so many things are there. Understood? So much. Okay, now first the person who actually wrote a book on light is, can you guess who? Sir Isaac Newton. In his books Optics. Maybe before Isaac Newton, so many people they was trying to understand light, but Isaac Newton tried to understand light. So in a book he Optics, he mentioned about light. In a book Optics, he mentioned about light. He called light is made up of particles. Light is actually particles. I discussed this last class for you, right? What are that particles name? Corpuscles. What there? Corpuscles. Light particles or corpuscles. They are the minute particles which are moving always in a straight line. That's what Newton says. Newton says light is made up of the small minute particles called corpuscles. That too, they are in spherical shape. They are moving with high speed and they are always moving in a straight line without deviation, he says. So Sir Isaac Newton is the first person who think about, who given information about light as particles and they are move in a straight line. So what is that concept he called? Straight line motion. Tell, what is the concept? Rectilinear propagation of light. You know? Rectilinear propagation. Don't know? Rectilinear propagation of light. Rectilinear propagation of light. What propagation? Rectilinear propagation. What is rectilinear propagation of light? Rectilinear means what? Light always move in a straight line. Light always move in a straight line. It will never bend. It will bend. It will not deviate. It will not move in a curved or change. It's never change the direction. It will always go in a straight line. This is what Newton says. And why he says like this? He says because they are particles. The particles will travel in space in a straight line. Okay, and they are illuminating. They're giving light. They're giving that brightness. So this is what Newton says. Why Newton come to that conclusion? That is true. Rectilinear propagation is true. Yes, light travels in a straight line. And also Newton says so many things. I will discuss that now. Shall I change the next slide? So, as a light travel in a straight line as a particles, what is the conclusion? Like, what is the evidence for this? He says, whenever, for example, light falls on any surface, okay, whenever light falls on any surface, the light rays are again getting reflected back with the same direction, not same direction. They are reflecting back. Understood? They are incidenting with some angle with theta and they are reflecting with the same angle theta. Whether it's angle same or different, it's not a matter. When this is the nature of a particle. A particle, what it will do? Whenever it will incident on one surface, understood? It will bounce back. Correct, right? A particle, what it will do? It will incident on the surface. Again, it will bounce back. This is the property of a particle. So Newton assumed it. Yes, if it is hitting on the hard surface, it is going back again. It's bouncing. So definitely then light is a particle. That's what this assumption. Particles there, corpuscles. That too, light particles are coming in the form of straight line, rectilinear propagation. That's why the name gave it, ray optics, rays. They are coming in a straight line. Understood? And you know these things. Everyone knows this. When light falls on the surface of glass, sorry, for example, mirror you take. When the light falls in a mirror, what happens? Reflection is happening. It is light is coming back. Correct, right? That's why it is. That's why the light is a particle. Who said? Newton said. Understood? Why Newton says it? He has some evidence. And you also see one more thing. When light falls on water or when light falls on a glass slab, the light rays are going inside it, inside that medium, glass medium or water. Correct, right? They are traveling inside. Why they are traveling inside? Because the medium may be transparent. The density of the medium is maybe less. Understood? And the light particles are so minute that they are passing inside that medium also. But their speed is reducing. The light speed is reducing. This is what I observed by Newton. Okay, whenever light is, for example, going through the water or glass, I will take one glass slab, or you take any water. So what happens when light falls on it? What he observed is, okay, it is bending. It is bending. It's not going in the same direction. It is bending. And when after glass slab again it is bending away from the normal. You should understand what is normal, what is normal. I will just discuss this. Wait. Otherwise, it's difficult to understand. Simple thing. Whenever you take any the medium, for example, I will take a glass medium. Okay. The glass medium above is air medium. Air medium will be there. Light will always travel in a straight line in the air medium. It will move in a rectilinear propagation. Correct, right? Now, for this surface, for this glass surface, what is the normal to the surface? A 90 degree. Normal means 90 degree dotted line, right? 90 degree. One normal you draw is the normal. Normal means understood. For that surface, there will be a normal direction. Okay. So this is 90 degree. N and N dash, I will take it as normal. Normal. This normal, this ray is making an angle theta, incident angle I. This ray is making an angle, incident angle I with the glass. Now what happens? Newton what I observed, okay, but the light ray should pass like in the same direction, but because it is bended, no problem. It should pass in this direction, but what happens? It is bended like this. Now again it is bended away. Now you see, okay, something is happening. Light is actually bending means its velocity also decreasing. Its velocity is decreasing. That means because it is passing from rarer medium, that is air, to the glass denser medium, it slowly velocity decreases because glass particles will not allow easily the light particles. So he said, oh, particles there. Even if you see in water, water is there. Okay, you see some person will absorb water, or some tiger or lion will absorb. What it will see? What it will see? Reflection it will see, and also for tigers, animals, they will not understand. But we understand, no? Some refraction also. The light travels and deep inside the water pond, you can see things, right? Correct, no? Deep inside the swimming pool, you will see, no, what is there. Why? Because light is passing inside. Otherwise, how you will see? Because light is going, penetrating inside. And even light is reflecting. So the tigers are animals. That's why whenever they will see water, no, first time, no, they will, what they will do? You know? They look scared, huh? Their image they will see and they think, oh, other animal is there, which is trying to, yeah, and it is doing the same way what I am doing, like what Venu do. So this is the problem. I mean, it's not a problem, it's the nature. That's what light, this is what Newton observed, and he said, okay, light is a particle only. Because particle only, if you throw a stone on the, throw a ball, a particle, on the surface, it will bounce back. If you throw something on water, what it will do? Eh? It will go inside. So, yes. Stone, if you throw, it will go inside because it's a particle, big particle. So that's what Newton's thinking. It's natural. So Newton says it's the particles. That's why it is ray optics. He proved there is reflection of light. Reflection and refraction both are happening. So I am telling light is a particle. Please take this information. He said. Who said? Newton. He gave the one book and he submitted to Royal Society in England. So they proved, okay, light is a particle. Refraction. Light is a particle. Light is a particle. He said, who said? Newton said. Okay. So this is what basic information about ray optics. Optics. It's the study of light and instruments which are used in light, like glass, lenses, mirrors, everything. Now you see, what is, if you want to go into study about, the basics of ray optics, you need so much information. What is transparent medium? What is transparent medium means? A medium which allow the light to pass through it. That's a transparent medium. Opaque medium means it will not allow. Correct, right? What is isotropic medium? Isotropic, anisotropic, studied in chemistry. Iso means same. Iso means same. Tropic means? Isotropic medium means what? Okay, understood? Isotropic medium is a medium where the material content is same. Glass. Okay, there should not be different particles. Same glass particles should be there. Only medium, same medium. Now you see, basically we should know about what is object, what is image, what is real object, what is virtual object to understand this chapter. Can you say what is object means? Object? Huh? What is object? Sleeping menu. Product? What is object means? An object is a source of light. An object is a source of light. Why that much difficult to find, understand? The light source will come from the object itself. It's a source of light. It is a source of light tree. Source of light tree. It's a source of light ray. Light ray will come from the object only. Understood? It's a source of light ray. There are two types of objects. Number one is real object. Please take real object. Real object. Number two is virtual object. Virtual object. Can you say what is real object? See, if you not talk, no, what is the use of doing class? No use. You should answer me fast. What is the real object? An object is said to be real object when the light rays are emerging from one point, a source. Then that object is real object. For example, I will take one object. Okay, this is object. The light rays are emerging from this point, source, to the, for example, lens or a mirror. Now what happens? Okay, light rays are emerging from this point and moving on the lens or a screen. You take anything. That is what we call point object, real object. Understood? What is virtual object then? You can tell now. What is virtual object? Real object means what? Whenever the light source is, whenever the rays are coming from one source, one light source, one point object, this object. A point object means what? You know what is a point object? An object is said to be point object when its dimensions are very small. Understood? Now this point object is giving a light source, and you can also say one, sometimes a point object means if you take so many objects, if the size of the object is very less than the distance between the objects, no? Okay, that is also called point object. Two objects are there or five objects are there. If the distance between the objects is more compared to the size of the object, then it is also said to be point object. Okay. Now you see, this from this object light rays are emerging. They are all emerging and falling on the screen. They are falling on the screen. This is what we call real object. This is what we call real object. Okay. Now what is virtual object? Virtual object. What is virtual object? Same thing, reverse. If the light rays are trying to, if the light rays are coming, okay, from some different, source, okay, the light rays are coming, and when they are falling on the lens or a mirror, anything, they will try to meet at one point, right? After, okay, it appears that after falling on the lens or mirror, they will meet at a point. That is, this point is what we call virtual object. Yes. Virtual object means what? The light rays are coming and it appears to meet at one point in the back side of the lens or a mirror. Understood? Or in a screen. It appears. That is what virtual object. Real object means it will direct give light source. Understood? Please take this. This basic information you don't know. You know? You ma? Not learned, huh? Fast. Okay. Done now? Yes. So here, listen here. Here, the light rays are moving from one point source. That is what we call real object. Here, what happens? They're trying to converge at one point. That converging point is called virtual object. Okay. Now, what is the image? What is image? What is image? Picture. after after the light ray from the object moves through a lens or a mirror, it will form an image. It will form on the other side of that lens or a mirror. That light rays will either converge or diverges. After moving from the object to the optical instruments, okay, the light rays either they converge or diverge from the optical instruments, forms an image. Please write. Image is, it is the convergence or divergence, it is the convergence of light ray, convergence of light or appear to diverge, appear to diverge from the point source, okay, from the optical instruments, sorry, from the instruments, optical instruments, forms an image, forms an image. It is the convergence of light or appear to diverge from the optical instruments, forms an, okay, a light, you write, wait. A light that converges, you write, a light rays or a light rays, you write, rays that converges, oh, some, a light that rays that means light rays that converges or appear to diverges from the optical instruments, forms an image, forms an image. Two types of images are there. What are the two types of images? Number one, real image. Number one, real image. Number two, image, image. Number two is virtual image. Real image and virtual image. What is real image? That is object. From object, the light source will come out, emerge. That is real object. What is real image? You see, real image means, for example, I will take one one lens or a mirror, any one optical medium. So when after the light rays, okay, after the light rays passing through this optical medium, this is an optical instrument or optical medium. It is an optical medium. When the light rays after passing through optical medium meet at one point, That point is what we call, this is called image, and the image is real image. They will now converge at one point. They will meet at a one point. See, a light rays will come from here. This is the real object. It will come, it will fall, and it will meet here. Now image, real image was what? This is the real image. Understood? Okay, for example, you take any convex lens. A convex lens means all light rays, when they fall on the convex lens from any source, okay, what happens? These all light rays just meet at a point. This point is what we call the point. That point is what we call focal length, focal point, focus, and the image forms there is real image. ಅದು ಕನ್ವರ್ಜ್ ಆಗುತ್ತೆ. Object reverse. Object ಅಲ್ಲಿ virtual object means what? The light rays will converge in the behind this optical instrument. That is what we call real image in the case of images. Okay, you say, take for example mirror. If you take for example mirror, when the light rays incident on a mirror, what happens? They will meet at one point. Okay, and this is center of curvature, for example. So they will, this is the image. You see, these two lines meet at the point. That is the image. One light ray is coming like this, another light ray is coming in, both are meeting at the point. That meeting of the light rays, converging of light rays after reflecting from the, or reflecting or refracting from the optical instruments is what we call real image. Please take. Second one is virtual image. What is virtual image? Yes. When the light rays diverge from the optical instrument. I am seeing from that time full sleeping. Basics ಗೊತ್ತಿಲ್ವಾ? No problem, learn. Done. Done. Next. Okay. Now you understood what is virtual image. Virtual image. Listen here. So what is virtual image? When the light rays falls on any surface or any optical medium, this is optical medium. When the falls, the light rays just fall on the optical, oh sorry, for example fall, okay, two light rays just fall. Okay, now these are the light rays which are falling. Now what happens? They will reflect back. Oh sorry, one minute. Yeah, when the light rays falls like this, so they will come like this, correct, right? They will meet somewhere. That is what virtual image. The where they will meet now, they are, that is called virtual image. Some light rays, what they will do, I mean sometimes this is a surface, they will come like this, they will go like this. See, somewhere they are going diverging, no, somewhere it will form image. That is what we call virtual image. They will not meet at one point. Here also I think it will not work, come virtual image actually. It is reflecting back. So this is correct example. When they fall and they will just go somewhere, they will meet, big image will get. Okay, that's what virtual image. Understood? Real images, they will meet at the point. Understood? So these are the basic things. So much is there actually. What is the properties of real image and virtual image? What I'll explain that. Now you see. So real image and virtual image. So real image means what? Any surface, if they fall, if the light rays are coming and falling on the optical medium, what will happen? They will meet at one point. Okay, this is not clearly, it is getting here. That's what I am trying. See? Arrival, image forms here. And that image, this is in this case, for example, you take in the mirror, this object, light rays falls on the surface of a spherical mirror, convex, it's not convex, concave mirror. So concave mirror, after falling, it will just meet it, the image will form here. Okay, understood? So this image is a very minute size. Okay, if the object is, for example, like this, image you will get is in this ulta, reverse. So what is the nature of the image? Real image is, it is, I am talking only about real image. So real image nature is, it is inverted. If you take this pen, you keep this pen like this. Okay, if you get a real image of this, it will become ulta. Understood? Okay, if you want to, you just open your the spoon, the eating spoon, no? Okay, tiffin spoon. If you just see, you will get concave mirror. You just see like this. How you will eat the concave you keep, then you will see your face will be reversed, and it will be small, diminished. Inverted is one character, and another one is diminished. Diminished. That is the property of the real image. Okay, virtual image is not diminished, it's enlarged. Inverted and diminished. Understood? Now if you take virtual image, so virtual image, you know how it will form. It will come, when the light rays falls, they will just reflect back, means somewhere the image will just form. 1 minute. So what is the nature of the virtual image? What? Is real image. Object virtual. Is misunderstanding. So somewhere virtual object, virtual image forms, and the image, virtual image, you can explain basically in terms of convex mirror. Okay, convex mirror. See, this is convex mirror. When the light rays falls on the convex mirror, they will diverge like this. See, and somewhere the image forms here. Okay, what is the, by conclusion, what you can say? Here the object is smaller and image is enlarged. Image is enlarged, bigger. enlarged image, number one. Number two, what else? Diminished, enlarged. It is inverted as same. Object and image is same, upright. Upright means what? It is not inverted. See, here object is like this, image is ulta. Object hingidre image hingirutte, ulta irutte. Adre illi object same, image same direction. That's why it is upright and it is enlarged. Image is also enlarged. Take. These are the properties of the real images. This virtual image, this real image will caught on the screen. Okay, this is a, for example, lens, optical lens or a optical instrument, and here it is a screen. This will caught on the screen. You will get on the screen the image, but this virtual image, it will not get in the screen. It will not caught on the screen. Understood? So please write that. Third point, it doesn't caught on the screen, does not caught on the screen. Real image will caught on the screen. Caught on screen. Fast, fast, fast. Somewhere it will meet. Yes, next. Done now. Write these points. Done now. Yes. Next. What is understood? What is virtual image and real image means? What is real image? It's inverted and diminished means the light rays are converge at the point. When after passing through the optical medium, the light rays converge at the point and they will caught on the screen. You will get the image on the screen, caught on the screen. But virtual image is not like that. Okay, when they fall on the any optical medium, okay, when they, for example, this light rays are falling on the optical surface, they will see, they will not caught on the screen. Back side of the screen, they will not caught on the screen. This is the virtual image. Understood? Okay. So this is very enlarged also. That I explained even in the using convex lens, convex mirror. Sorry. Now please take the heading reflection. Heading reflection. What is reflection? I discussed it already. When the light ray passes from one medium to another medium, not one medium to another medium, okay. And when the light ray falls on any medium, okay, this is for example x and x dash, I will take just surface of the medium. This is one medium, for example, glass. When the light ray or any opaque medium, opaque means a wall where light will not allowed, the light will not allowed by that medium. Now when the light ray, for example O and O dash, just falls on the surface of the medium, it will reflect back. It will reflect back. Incident and it will reflect. It will bounce back to the same medium. That phenomena is called reflection of light. Reflection of light is what? It is the bouncing back of a light particle, bouncing back of light back of light to the same medium, to the same medium, to the same medium, bouncing back of the light to the seed medium when light travels from one medium to another medium. When light travels from travels or hits the surface of another medium. You write when light incident on the travels beta, incident on the surface of on the surface of another medium. Correct, no? For example, it will traveling from air medium to glass medium. Some of the light rays will reflect. They will come back to the same medium. It's not like everything are the same. Otherwise, no, in water also. Why you are seeing your reflection? Because there is a phenomenon of light. Okay, all light rays will not undergo reflection. Okay, some they will refraction. What is the loss of refraction? Reflection. Loss of reflection. What are the loss of reflection? Number one, the incident ray, the reflected ray, and the normal to the point of incidence are all lie in the same plane. What it means? You see, this is a normal. Okay, please take this diagram. The incident ray, you see here, everyone's here. The light ray starts incidenting like this, Tup, and it will come back. Correct, right? It will tup, tup, it will go. When light ray incident, it will come back to the same plane. Plane is same. For example, xy plane. Okay, this is y axis, this is x axis. So xy plane it is. Now it will incident, come back. Same plane. The plane is same. Understood? Here you see, this is x axis and this is y axis, y dash. You see, incident and in the reflected all are in xy plane only, no? Is it another plane, mister? Another plane is there? Z plane is there? No, z axis not. Only xy plane. So that's why the incident ray, write down. The incident ray, incident ray, incident ray, reflected ray, reflected ray, and normal to the point of incidence, normal to the point of incidence are all lie in the same plane, are all lie in the same plane, lie in the same plane. See, such a nice. That is the first law of reflection. Okay, second law of reflection is the angle of incidence is always equal to angle of reflection, R. Angle I will be always equal to angle R. That is the second law. Every time, whenever the light ray is reflecting, the angle of incidence is equal to angle of reflection. Okay, please take. Angle of incidence equals to angle of reflection. Yes, done now. Hello, hello, hello. Haribol. Done, huh? Next. You see, next thing. What is a spherical mirror? Now, first we will go to mirrors. Spherical mirrors. What do you mean by mirror? This is the first topic. Okay, so, reflection we studied. Reflection in case of mirrors we will study. Okay, what is spherical mirror? What is a mirror? Okay, mirrors means actually they are the part of a halo sphere. Halo sphere will be there, no? What is halo sphere means? Huh? If you take a halo sphere, ball, cricket ball, halo sphere. A part of the halo sphere, a part of the halo sphere, you just take part, cut it, and that you will get as. Still, it's not a mirror. Okay, what we will do? We will silver the any one surface of the part of halo sphere. Okay, then you will get a mirror. What is silvering means? Covering with the thin film. Some thin film coating will do. Okay, that is what we call, now it is a spherical mirror. Spherical mirror, a part of a halo sphere. Understood? There are two types of this. Number one is concave mirror and number two is convex mirror. You know this, what? Concave and convex? Don't know? What? Tell. I cutted it. Now, what is convex mirror? Tell first. Convex mirror. This is the sphere. I just separated the part of the sphere, right? Now, what is convex mirror? Which side of the convex mirror we need to silver? Right side, huh? This one, huh? Okay, wrong. This one. This is, oh, convex, right? Yeah, this one. Inner surface of the spherical halo part of the spherical sphere, if you silvered, then it will form convex mirror. Okay, and here this is the principal axis of the mirror. This is concave mirror. Outer surface of the spherical mirror is silvered. Okay, it is concave mirror. ಯಾವ mirror? Concave mirror. This is convex mirror. I written already, right? Understood? You see here. You see here. Here, this is the pole of the mirror. Center of the mirror is what we call pole of the mirror. P is pole of the mirror. And the point where a light ray just meets is called principal focus of the mirror, and here R will be there. Sorry, C will be there. Center of curvature. Understood? Here also you see. Here it is the pole. Here it is F, and here it is C. Like that it will be there. What are that we will discuss now. You understood what is a mirror? It's a part of halo sphere. Okay, a part of halo sphere. Cut the part of halo sphere. Now this is a pole. If you silver on the inner side, it is convex mirror. If you silver on the outer surface, it is a concave mirror. Understood? Understood now, Raju? Now here, this C is there, no? This is the center of curvature. What it means? It is the center of a halo spherical sphere. Halo sphere. If you continues the sphere, no, it is a halo sphere. The center of the halo sphere is the center of curvature. Okay, so right here, C is center of curvature. C is center of curvature. And F is focal length. What is focal length? Or focal point? Actually, this focal length you should not take. It is principal focus. F. F is principal focus. F. Principal focus. Principal focus. I will tell. The distance between F and pole is focal length. F, small f. Okay. Focal length means distance between F and P, pole. Center of curvature, from the distance between center of curvature and pole is radius of curvature. What we call? Radius. It is the distance between center of curvature and pole. Radius of curvature. Okay? Please take fast, fast. Very, very slow here. Done now? So pole is the center of the mirror, and this one is what? X and X dash is the axis. Principal axis also you can tell. Here you see. What happened? This you see, this distance X and X dash is there, no? This is principal axis. Sorry. Principal axis of the mirror or lens. Even for lens also it's same. Okay. While doing the lens, I will not discuss all these things. I am telling now only. Is it you want me to discuss? Okay, the battery is running low here. What is the time now? Okay, 8 minutes. Done. Very good. Now you see, you understood all of that? Okay, if you have doubt, you ask. So whenever, when the light rays are, for example, moving, see, for example, this is a spherical surface, convex mirror, not convex, concave mirror. So concave mirror I am taking. This is the principal axis, X and X dash. X and X dash is principal axis. This is pole of the mirror. Okay. Now you see everyone. See, when a light source falls, okay, this is the object. When the light source falls on the surface of the mirror, it will just meet at one point. Okay, this point where the light meets, right? All the light. Understood? Okay, one light ray meets here, then another light ray just go like this. Wait. This there is. It's not good to explain like this. Now you see, I will take one mirror. Which mirror it is? Concave mirror. This is X dash. when light source falls on the mirror, okay, here it is object, and here again you see this is the center of curvature, for example C. Okay, now image forms here, image forms here, understood? So where these light rays are all meeting at the one point on the axis, for example this is the point, so this is the point where all light rays actually meet, that point and the is called principal focus, and the plane where the image forms is called focal plane. What plane? Focal plane. Focal plane means the plane where image forms. You can write this plane, focal plane, understood? Their image forms, because light rays will just falls and they will meet at that point and the plane. Okay, so that is what focal plane, understood? Now now we will discuss Cartesian sign conventions. Write down, take the heading, Cartesian sign conventions. Cartesian sign conventions. Sign conventions. What are Cartesian sign conventions? Number one. Oh, okay. I will discuss this. See, these are the sign conventions. Signs you need to use whenever you are measuring the object or image, where object is, where image is, whether you need to take object distance positive, image distance positive, object distance negative, image distance negative, focal length positive and negative, radius of curvature positive and negative, like this. You will observe this. These are called Cartesian sign conventions. Sign means, you know, right, applying signs, positive and negative. Whenever you see, so this is a one mirror, whether it is convex mirror or concave mirror, anything is fine. What is this? Pole of the mirror, correct, right? Pole of the mirror. Always, for example, here one object is there, here one object is there, object. The object, what is the distance, what is the object distance? It is the distance from pole to object. All measurements we will measure from the pole of the mirror, or a mirror. This is a mirror we are using. Even for lens also, all the distance are measured from the pole of the mirror. This is a mirror, right? Okay, you'll get confused, I think. Mirror means we should put these lines. Okay, all distance are measured from the pole of the mirror. So this is, see, this is the object distance u. If for example image somewhere, it will form somewhere like this. Okay, this is I, image distance v, like this. Understood? Understood? And this is the center of, this is for example focal length f. This is a focal length f. F is the focal length. Here it is principal focus, and this is C. So distance between center of curvature and pole is radius of curvature. So every measurements where you will do, all measurements you will measure from the pole. Pole is the basis. From pole everything you will measure. Understood? So that's what, that is the first point. The point is all distances are measured from the, all distances are measured from the pole of the mirror, measured from the pole of the mirror. Correct, huh? All distances are measured from the pole of the mirror. See, everything we measured from the pole of the mirror. Understood? Next point. Now, here, for example, object is there. I will take one object here. Okay, object. From the object, the light will come. Light source is from the object. Correct, right? Whenever you are measuring any distances, for example, radius of curvature, image distance or object distance, you will measure from the where? Pole. From the pole you will measure the object. But the light ray is in which direction? It is opposite to the measurement. Correct, right? Light ray is going like this, but you are measuring from pole. You are measuring left direction, light ray is going right direction. So that's why the measurements which are against the direction of light ray is taken as negative. Okay, the measurements, for example, object distance is positive or negative?
Object is negative.
Negative. Because object distance we are measuring from pole to object. But the light ray is in which direction? The object is we are measuring left side. Light ray is in right side. That's why negative. Light ray is going right side, but we are measuring on left side. Okay. All the distances measured against the direction of light ray is taken as negative. All the distances measured in the direction of light ray is positive. In the direction of light ray in the direction of light ray are positive. Light are positive, but opposite to the direction of light ray are taken as negative. Opposite to the direction of light ray is taken as negative. Are taken as negative. Done? Understood? If the object is that side, then object is that side, then now, for example, your light rays are going like this, and you are keeping the center of curvature this side, C. So it's not like that, but you are measuring the center of curvature opposite side. Now, what is the from pole you are measuring that side, and light ray is also measuring going that side. So both are in the same direction, means center of curvature is positive. Will take. Okay, but whenever in the mirrors we will not take like that. We will always consider this side because it is a concave mirror. Cave, this side. Cave mirror means what? It is creating a cave. The light is falling on the cave. That's why it is concave mirror. Don't confuse with convex and concave. Next, the third last point. Okay. Listen here. If you take the height of a object or image, okay, height of the object or image, above the principal axis they are positive, below the principal axis they are negative. Heights above the principal axis are positive, write down. Height of object or image above the principal axis is positive. Above the principal axis is positive. Axis is positive, and below is negative. Below it is negative. Done? Yes, very nice. That is the Cartesian sign conventions. Okay, so we'll continue in the next class, whatever the remain. Thank you. Take care. Bye bye.